Okay, everybody, I think we will get started. I see a good number of attendees listening in. So I will just introduce myself quickly. First of all, welcome to the panel discussion, a professional development panel discussion. And this one is geared towards graduate school. We're going to do graduate school first, and then in about 30 minutes, we're going to do an industry version as well. Myself, I'm Professor Chris Malone, and I teach statistics and data science courses here at Winona State University. And we have a couple of colleagues that we've asked to participate in this. I'll let them introduce themselves. I'll just maybe mention their names and their affiliations, and that's Kurt Cogswell from South Dakota State University, and also Lance Waller from Emory University. So I'll let you guys go ahead and introduce yourselves to the audience.
Okay, am I up first?
Yep, go ahead, Kurt.
This is Kurt Cogswell. I'm the professor and department head at South Dakota State University in the Department of Math and Statistics. Started out my education in physics, started a PhD in physics, switched to math when I discovered that the mathematicians were answering the questions I was interested in. And now that I'm surrounded by statisticians in my department, I'm discovering what a beautiful discipline statistics is, so I wouldn't be surprised if I end up completely moving into mathematical statistics as an area of research.
Okay, Lance?
Yes, I'm Lance Waller. I'm a professor and department chair in the Department of Biostatistics and Bioinformatics within the Rollins School of Public Health at Emory University. So I started with a bachelor's degree in math at Mexico State. I went to graduate school in operations research, and after obtaining my PhD, have been a faculty member in 3 different departments of biostatistics, all in schools of public health at University of Alabama, Birmingham, then the University of Minnesota, and for the last 18 years at Emory.
Okay, thank you. I've identified a handful of questions for both Kirk and Lance to maybe address. I've asked them to address, I guess. I should have said there will definitely be time here at the end for question and answer as well. So audience members, just go ahead and type your questions in the chat box, and I will be moderating those, and I can pass those on to both Kirk and Lance. My first question then, first planted question, is grad school for me? So Kirk, do you want to take that one first?
Sure, you bet. I guess I'd say first, grad school is not for you if you can't think of anything better to do. That would be one disqualifying factor. If that's your only reason for going to grad school, then maybe wait a year and rethink. 2 good reasons are for professional betterment and just because you love the discipline and you just can't wait to learn more about whatever it is you're studying. So for example, if you are looking for professional improvement, a professional degree, for example, at South Dakota State, that's our master's in data science degree might be for you. If you love math and statistics and you just want to learn more and also substantially better your professional prospects, a traditional degree like a master's in math or a master's in statistics might be for you.
Okay.
And I'll echo some points Kurt made. I think a master's degree, if you're not quite sure if you're ready to go to work or if you really want to dig in for the next 3 or 4 years, I think a big part of graduate school is learning new things, and you learn them faster than you do in an undergraduate. The information comes at you faster. You need to figure things out. And I added, are you stubborn or persistent? Because if you don't get something right away, because you're moving into areas of the field fewer people understand, do you want to stick with it? So I think those are some tenacity components that would go along with staying in graduate school as well.
Okay, thank you, you too. Second question that I asked them to consider is, how should I prepare? And I'm talking about coursework. So maybe Lance, you can go first on this one.
Okay, so I have the shorter list there. Just the basic requirements on the math side are multivariate calculus and linear algebra. You should also take as much computing as you can or comfortable with, because you'll be doing a lot of it. Kurt's added some additional details that I'll let him speak about that are important. But make sure you have the requirements for the programs you're interested in. And one question we get is whether you should have a master's degree before applying for a PhD. About half of our incoming PhD class has a master's degree. It doesn't necessarily give them a leg up, but it does give them a couple of years additional experience and exposure to the material.
Right. And actually, my list is, oh, Lance, are you done?
Okay. Yeah, I am done. You can go ahead.
Okay. Yeah. I mean, my list is remarkably similar to Lance's, and that's unsurprising. So for a basic professional degree, like a master's in data science, multivariate calculus and linear algebra, just absolutely essential. Some sort of coding, the more the better, but at least be familiar with R or SAS or something like that. And if statistics classes, I think that's really to your advantage if you're thinking about moving on the data science or statistics path, just so you'll know what you're getting into. If you want to go on for a PhD or even a traditional master's in statistics, I'd encourage you to think about taking some higher level mathematics, for example, an undergraduate course in real analysis or advanced calculus. When you get into a PhD program in stat, you shouldn't be surprised if you're asked to take things like measure theoretic probability and so on. So you want to have a pretty good underpinning in advanced mathematics when you get to those good courses like that in graduate school.
All right, thank you. And then to contrast the coursework, how should I prepare for graduate school? Maybe other things that I can do but outside of the class. So, Kirk, maybe you go first on this one.
Sure. I pick up a little bit on something that Lance said a minute ago, which is grad school moves faster and the expectations are higher. One thing we expect you to do is know the things that came before in your education. So I'd recommend the summer before you start grad school, sitting down and reviewing the coursework you've taken in the areas that both Lance and I talked about as being essential for grad school success. Spend some time on it that previous summer. But then, and I think it's not more important than coursework, but I'd say as important, do something when you're as an undergraduate in which you complete a substantial project, whatever that may be. It could be an internship, a modeling competition, undergraduate research. There's just something about that experience of taking a project from beginning to completion, reporting on it, working through all the details and all the hassles that come with that. It's a great experience to give you a feel for what it's really like to be a statistician or data scientist. And it really improves your chances of being accepted into the graduate school that you would prefer.
Okay, thank you. Lance, want to add to that?
I'll agree with that. If you have research experience, it doesn't matter if you have a master's degree or not, that really stands out in your application to a PhD program. And it stands out in your application to a master's program too, just for the reasons Kurt said. You've seen something from the beginning to the end and you've written it up to explain your results. In addition, I'll add, there are a lot of summer programs, specific ones. REU is a research experience for undergraduates. SIBS is a program at 6 different universities that introduces about 20 to 25 undergraduates a year to biostatistics with a little bit of training, some project-based, and then interviews and discussions with current faculty. It's sponsored by the National Institutes of Health, and the applications will be opening soon. The research experiences we mentioned, I think the American Statistical Association's internship list is very good. Not all of them are available to undergraduates, but you can show you the wide variety of jobs you can go into and the experiences you can have. The modeling competitions, hackathons, anything that sort of exposes you to problem solving in addition to the technical calculations will really help you out, and it's a good thing to put in your application.
All right. Thank you there for that good advice. Just letting the audience know, again, if you have questions, please type those into the chat window there. The chat window is not very active yet, so we will, in a few minutes here, stop for a question and answer session. So go ahead and push your questions into the chat window, and then I will ask both Lance and Kurt those. Thank you. All right. On to the next one that I had prepared ahead of time, and that is, I often give it the advice of being prepared for the unexpected. You got to expect the unexpected. So I've asked both Kirk and Lance to address what are some of the things that students find are kind of unexpected when they get started into graduate school. So I don't remember where I left off. Is Lance the first one on this one?
I can go first. Yeah. The first one is a bullet that surprised me. It came to me about the third year of my graduate studies, and I had been a good undergraduate student. I could do problems they showed me how to do, but if I got a new type of problem, I was struggling a lot. And I remember throwing a book down on my table saying, they're writing it like it's supposed to make sense. And then there was this little light bulb in my head that it is supposed to make sense. And if it doesn't make sense in terms of what answers should look like, I'm never going to be able to do anything new. I can just redo what someone's shown me how to do. So there's an intuition to statistics, but nobody sits down and tells you what it is. You have to figure it out for yourself. So if you start looking for connections, pretty soon you find them, but that was a different type of learning for me. And then the second one is just reiterating that you take fewer classes at a time in graduate school, but they do take a lot of time. So you're going from things that everyone in the field knows, the general stuff you take in a first statistics class, to things only a few people in the world know. And that happens in maybe a 4-year period, 5-year period, getting a PhD. That's an incredibly short amount of time to cover decades worth of material. So I don't say that to scare people off, but I do think that stubbornness needs to pay off. You can get there, but you have to recognize that you're going to be swimming with a pretty strong current.
All right. Go ahead, Kurt.
Well, the one thing I think that takes many new graduate students by surprise is that they're no longer necessarily the smartest person in the room. That's what makes graduate school exciting, but it's also, it sets some people back just a little bit, because all of a sudden they're used to excelling without much effort, and now there's quite a strong self-selection process that goes on with admission into graduate school. So you might not stand out as much as you did before. That's not a bad thing. This is an opportunity for you. So I hope that if that occurs to you, that you just grab it and relish it. And the next point I made is very similar. This may be the first time that some people struggle with mathematics or statistics. And that, again, that's an opportunity. And you should not panic if that happens. That's a very natural part of the process. You hope you get to the point where you are challenged up until you really have to persist and struggle to get through something. That's when you're growing as a statistician. And then finally, and especially in an area like statistics, which is so incredibly rich and broad and diverse, it's completely common to end up specializing in some area you've never even heard of when you got to graduate school. So keep an open mind, take a course, go to a seminar that in some topic that you might not think sounds very interesting, or you might not know anything about at all, and you might find the thing that drives the rest of your professional career. I see that happen time and again, so please keep an open mind in graduate school. It's a very, very rich intellectual life, and grab it and run with it for all it's worth.
Yeah, that's good advice, Kurt. That was one of the most fun times of my education was graduate school. You're just surrounded by people that very much enjoy what you're doing. So good advice there.
And that's
I think
the time
this is,
you have. I was just going to add that you have 3 or 4 or 5 years to just mostly sit and think about stuff that you love. That may never happen to you again. As a faculty member, you have committees, you have grading, you have all sorts of stuff to do. So graduate school is really just an amazingly great opportunity.
all right. Very good. I guess the last slide is just what kind of lifelong advice do you have for these undergrads that are thinking about maybe going to graduate school? And I'll let Kurt go first on this one, I think.
Okay. I would say that you may not think of it this way, but if you're going into a field like statistics, your graduate program is where you start to build a professional reputation. And if on day one you are a reliable and collegial person, that's going to work. By reliable, I mean just some of the basic nuts and bolts. Show up, get your assignments in on time. If you're a graduate assistant, be available, respond to emails in a timely manner. Just very, very simple things, but it's surprising how many people are not good at that. And if you are, you can make yourself stand out by doing what you might think are just mundane, everyday sorts of behaviors. I would say don't get behind in graduate school. Every time there's a class meeting, as soon as you can afterwards, sit down and review that material. At least have thought about it before the next meeting of that class. If I walk into class and I ask the class, okay, what's the definition of a certain term we had last class meeting, and nobody knows, I've got a pretty good idea that much of what I say that day is going to go right past you. So, and I expect you to know what we talked about at the last class meeting and the one before and the one before. Not at a level of mastery, but at least familiarity so you can build new ideas on old. And then finally, it's pretty common. I mean, statisticians and mathematicians are pretty sharp. They're used to figuring things out on their own. You get to graduate school, you're going to run into stuff that stumps you. Don't be proud. Work on it for a point. Persist, try to figure it out on your own. But if you're running the risk of getting too far behind in a given class, please come to your faculty members and ask us for help. We love to work with you on things like that. Form study groups with the other graduate students. Learn from each other. Help each other out. You'll make lifelong friends, lifelong professional colleagues, and you'll just learn more and have more fun in graduate school if you do that. So those would be my three big sort of life lessons I learned in graduate school I hope you'll pick up on and take forward in your own graduate school careers.
All right, thank you. Lance, what lifelong advice do you have there?
Some advice I give to our current graduate students is read as much as you can and write as much as you can. I think Kurt made a good point about being curious and going to keep an open mind on topics. Go to a seminar that you might not know anything about. Read a paper. I learned a lot when my advisor I was a research assistant helping out on a project, and I was sent to the library back in the olden days, so we had to get paper copies. And I would always read I'd make a second copy and read it for myself. You can do the same thing with the PDFs. Kind of follow the track of what people write about, kind of watch them discover it. You don't have to master every paper you read, but get the idea of what kind of questions people are trying to answer with what kind of data. And then practice writing. Trying to write down your ideas in addition to the mathematics, I think, is critically important. When you're applying to graduate school, it's not some advice on graduate school, but applications, make sure your application reflects what's unique about you, your experiences, and so on. We read stacks and stacks of applications, so you have to, right before you send it in, read your copy and imagine that someone just read 25 pretty good applications. Why should they spend some extra time on yours? So put in your research experiences, your competitions. Write about something that didn't go so well and how you handled it. We need to see a unique person there, not just somebody who's good at math. We already have your scores and your transcripts on that. The last one goes to Kurt's point about you may not be the smartest kid in the room anymore. And when something that often happens in graduate school, or it's pretty common, is something called the imposter syndrome. And when you first struggle, where you haven't struggled before, a lot of people tend to turn in and they say, oh, I got in by mistake. And once they find that out, they're going to kick me out. That's not the case really at all. We're pushing everybody. So everybody in the room kind of feels like this. And the more that you talk to each other, in the study groups, and you start learning the material with other smart people, you'll feel less like an isolated imposter and more like a colleague trying to figure out a hard problem, because that's really what graduate school is about. You're with the smartest people around working on some of the hardest problems available.
All right, very good. Thank you both for addressing the questions that I asked both Lance and Kurt to consider. We do now certainly have some time for questions. I have a couple that have been coming through the chat window. But again, go ahead and submit questions through the chat window, and we will try to get those answered here in the next 5 minutes or 6 minutes, whatever we have left here. So the first question that I have through the chat window is from, I think it's Rahitka. What is the best path for a recent graduate to take if they wish to pursue a biostatistics career? So it looks like they've already graduated from undergrad, and they want to know what is the best path to pursue a biostatistics career.
I think the summer programs are good, as you mentioned. There may also be internships with, say, a pharmaceutical company like Eli Lilly or Merck. I think it's actually a good idea to look up the biostatistics department, send the department chair, or if there's a contact for student questions, send them an email and say you're interested. I have multiple conversations on the phone or by Skype with students doing exactly that. I might be interested in biostatistics, and I think it's part of my job to talk to them about what's involved in that. I think one of the things you'll need to think about is perhaps you apply for a master's program to try it out. That gets you on track for a biostatistics career, and there are a lot of jobs for people with a master's degree in biostatistics. Or you may talk to them and find out that you're interested in the PhD program, and you may be able to either work for a year while you put your application together, or take some additional courses, or there are several post-baccalaureate programs. We had a SIBS participant who decided relatively late to go into biostatistics, so he found a post-bac program at NIH and had his first paper published this last month, and now he's applying to graduate programs.
Okay, very good. Kirk, I think I'll pass along. I think Lance got that one good enough for us, but maybe you can take a first stab at Allison's question. And Allison's question is, do you think having a degree outside of mathematics, such as psychology, is beneficial to applying to grad school at a master's or PhD program in statistics? So she says she has a minor in math. Okay, so it looks like she has a degree in psychology with a minor in math, and she's wondering if, how would she go about writing her application to get into a master's program in statistics without having all the math that you talked about?
Well, at South Dakota State, it would definitely be to your advantage to have an area of expertise outside of mathematics. Even though we are a Department of Math and Statistics, and the statistics we do in our PhD program is very mathematical because it needs to be. We are all about the applications here. We're a land-grant university. We apply math and statistics to important problems, and psychology has some of the most important and the richest statistical problems available. So I would say if you apply to the master's degree program with a minor in mathematics, at ours probably good to go. If you wanted to go on for a PhD, we might ask you to take 1 or 2 additional senior level undergraduate math classes while you're in the master's program so that you'll be ready to go on to the next step mathematically in the PhD program. So a solid minor in math together with a degree in psychology or sociology, or even fields like agriculture and fields like that where statistics is heavily used, that's very appealing to me and our program. There might be other departments for which that's not true, so it's going to be kind of a case-by-case thing. And one thing you can do if you don't want to apply to scattershot to a bunch of schools, write to the graduate program coordinator or the department head and say, look, here's who I am, here are my circumstances, what do you think, would I fit in your program? If you contacted me with that and told me what I know about you, I would suggest that you apply and that you look upon very favorably.
Okay. I know when I was a student, we had a couple of students that didn't have that traditional background, and they really brought a different perspective on how to solve problems, which was nice. Lance did send me. Well, let's see if I can make that work. Is that going to work? Lance had sent me ahead of time Lance's list for graduate school success. So instead of my boring slide being on the screen, I'm going to just set that there, and then we'll take the next question. So that list there is due to Lance. So thanks, Lance, for sending.
I hand that out to our graduate students every year.
All right. Good advice on there. I agree. So Joe has a question coming through the chat then. What are some of the non-school challenges that graduate students have to deal with? So maybe things outside of the school, like maybe I don't know if he's asking about the assistantships maybe, or maybe just how to deal with being so far away from home, or maybe just anything along that line.
Time management's one of them because it can be all-consuming. You're giving a lot of problems that you could think about all day and often do think about all day, but you do have to stop and figure things out. So I think having a hobby is one of the things on my list. I think that's important to get a break from it every now and then, because when you come back to the problem, you often have new ideas. And the Frankenstein quote's there because I was in a book club. I like to read. That's my hobby.
Kirk, do you have any?
Well, just a quick point is that I'm thinking non-school challenges, maybe living arrangements. So you might be going halfway across the continent to a graduate program in an area where you've never been. Where do you live? It's frequently the case that the department to which you are will be arriving will help you, for example, meet roommates within the program or somehow help you find a suitable living arrangement so that that level of stress is taken off when you arrive in a new community. And Chris mentioned earlier graduate assistantships. It's worth knowing, and I find not everybody knows this. Typically in statistics, data science, mathematics, it's extremely common to have a graduate assistantship. So not only are you no longer paying for school, you are being paid a reasonable living wage to go to school. So because of that, if it's at all possible, I would encourage you not to work an additional job beyond your graduate assistantship. If you have a graduate assistantship and you're getting a master's degree or a PhD, that's more than enough to fill up your life. So if you don't have to work another 15 hours a week at a coffee shop, don't do it.
Okay. I just got another question that came in. It's quite lengthy here from Inera, so let me just read it and then I'll pass it on to you. Sorry about that, keep you hanging here. Okay, this Inera, I think it is, I-N-A-R-A, so I apologize if I'm saying that wrong. She says, I graduated with a major in economics and mathematics. I'm currently working as a data analyst, and they want to pursue a master's degree or PhD. Could get involved. Which would limit spend time? Any suggestions on what graduate schools? So, okay, it looks like major in economics and mathematics. They're looking for more applied programs, I gather here from what was written. In the last sentence there, any suggestions on what graduate schools would be good for that, or I would prefer?
It's also talking about she can do a lot of data analysis or a lot of writing. Would it matter what the balance is? I think making sure you can do the data analysis and write about it, as opposed to writing and do some data analysis on the side, is probably a good balance. You shouldn't ignore the writing, but the writing should be about the analysis to describe it to a range of technical people. And you mentioned blogging, which can be very helpful because you get some feedback and you also have a very heterogeneous audience reading it. So I do think it's good to have the writing experience, but what'll probably be best short term in moving into graduate school is making sure your programming and analysis skills are up, and always look for learning new things.
And do you have any graduate schools in mind, I guess, that would allow them to mix those together? I mean, I think any good applied, I mean, there's several applied programs out there. You know, you can get into pretty cool data analysis in those, and you know, most of the time, especially if it's a consulting position, you're going to have to write those up and explain that to the clients that you're working with.
Right, that's an essential skill. Yeah, and on the publication side, blogs are fine. If you're writing for a formal publication of the organization you're working for, that for me is going to carry a little more weight than writing for a blog post, although there's nothing wrong with the latter. But
Okay.
I would say we have any number of people that have moved into our Master's in Data Science program from our University Master's in Economics program. We love to have them. They bring a fresh perspective, and they will go out and do things with their data science knowledge that they gain here that our own straight mathematics graduates would never be able to do. So I think that you've developed an excellent background there, and I think you're on track for a good Master's in Stat or Data Science.
Okay, I'm going to have to cut off the panel there. We are up against our half-hour time slot, and this is going to be followed up immediately here, so we're going to switch over to the panel discussion for the industry folks, so please don't leave. I do want to just take a moment again to thank Kirk Cogswell from South Dakota State University and Lance Waller from Emory University. I really appreciate you taking some time out of your Friday afternoon here and sharing this good advice with the undergraduates here that are listening in. So thank you to the both of you, and I look forward to speaking to you soon. Thank you, everybody.
Have a good afternoon. Yes, bye.